Okay, so let's just see here. I gotta get rid of this. Okay, so do you guys remember when we were watching those videos? This is probably worth a red foot candy. Why did the Babylonians choose 360 as their base?
It was easily divisible by every base.
You were paying attention. Oh my God! So here I owe you a candy then for that. Yeah. Did anyone catch that? Can you explain what your
360 is easily divisible by pretty much every number 1 through 9 and 10.
So 360, 1, 2, 3, 4, 5, 6. It's not divisible by 7, but is it divisible by 8? Yep, it's divisible by 8. 9, 10, 12. There's so many numbers that it's divisible by that it's convenient to do math on. They also found out that with their calendar, I believe they had 360 days in a year, which is not bad, you know, thousands of years ago to predict that was how long it took to go around the Earth. But I believe that's where we get our system of measurement for circles from. So 360 degrees, that's, you know, it's basically just because things were convenient to them. It's not really a true measurement. Okay, so what is a true measurement? How do people deal with angles and things in the real world? Well, if you leave high school, nobody's going to talk about degrees anymore as soon as you walk out these doors. They're going to talk about a new system of measurement called Radian Measure. Okay, so the reason we deal with Radian Measure is we can actually put some quantities on here that aren't just made up like 360 is convenient to work with. So let's figure out how Radian Measure works, just so you guys get an idea for it. This is the formula for the circumference of a circle. Okay, so that's the circumference. This has a unit circle, meaning circle with radius 1. So what's the circumference of a unit circle? You don't have to give me the decimals. You can. What would it be here? It's meant to be really easy. Don't give me decimals. Don't give me decimals. Just 6. No. I mean, just what does it say? How are you getting the number 6? You don't know? Just magically, huh? 2 pi, right? So this is why we work with the radius 1, is because then basically when I multiply by 1, I get a circumference of 2 pi. Right? It's the radius kind of falls out of it. I don't have to do any calculations there. Okay, so the circumference of this circle is 2 pi. Okay. And what if we don't want the whole thing? Okay, what if we only want a portion? For example, if I only wanted a quarter of the circle, like it is down here, then what do you think? How much of this is a quarter of the circle? What do you think?
Divide by 4.
Divide what by? Yeah, half pi, because normally the whole way around is 2 pi, so 1/4 of the whole way around equals pi over 2. Okay, so let's try this again. What if we were to take an eighth? Pi over 4. Genius. How did you get that?
2 pi over 8 and then reduces.
Yeah, so 2 pi over 8 reduced is pi over 4. Okay, last one. It's a tough one. Can you do this in your head? What's half of the circle going to be?
Pi.
Good. Okay, so this is what Radian Measure does. Instead of talking about the angle in here, okay, instead of talking about this angle, Radian Measure describes how long the arc is made on a unit circle. So instead of saying 90 degrees, okay, we would say pi over 2, because if you take a unit circle and you put 90 degrees on it, you end up with pi over 2 for the length of that quarter circle. Now the reason why I'm saying we actually can measure these things out is if you think about what I have here, you can measure 1 unit. You know, depending on the accuracy you want, you can measure a length pi over 2, right? Put it in your calculator. You just need a couple rulers. Then you can give me a measurement for 90 degrees just by using the lengths and measurements that you had, right? With the degree system, everything you're trying to divide things up, right? You're taking 360, you're taking quarter, gets you to 90, taking eighths. You're basically just trying to cater to that system of 360 rather than real numbers like the radians are. Okay? So when you hear radians, you need to think arc length. Okay? So what's the equivalent arc length? Let's take a look at doing this conversion now. Okay, so we already said that 90 degrees is pi over 2. Okay. would 15 degrees be if we were to put this into radian measure? Any strategies, John?
Is it pi over 12?
I believe it is. How did you get that?
Divide 360 by 15 to see how many pieces there are.
Okay, hang on a second. Okay, so 360 divided by 15. And so how many pieces did you come up with? 24 pieces. Okay, that makes sense. So basically if we pictured it as a big pizza, there'd be 24 slices on this pizza. And no, I'm not going to draw all 24. But like John said, he's figured out how many slices of pizza. Maybe I am going to draw all 20. But anyways, I'm getting close. But that's not all 24. But he's figured out how many pieces he needs to make. So there were 24 individual slices. So that means it's going to be 1/24th of the original 360. So 24th of 2 pi, which was pi over 12. Okay. It's getting trickier now, right? It's not so intuitive as we pick harder fractions to come up with. So before we finish this, let's come up with a formula. How do we get from degrees into radians? Okay. Well, if we're going to make something equal, right? How do we get from 360 degrees? How many radians is 360 degrees? 2 pi. That's once around a unit circle. So if 360 degrees would be equal to 2 pi radians, then we can try to rearrange this to get a formula for converting degrees into radians. So 1 degree, how will we get 1 degree is equal to how many radians? Don't give me a number, use pi in your answer. This is an equation here, right? I know it looks funny and it's weird because there's degrees and radians and those are all new. But if you ignore everything else, how do you turn 360 degrees into 1?
Pi over 1.
Yeah, it's going to be pi over 180. So now we have a way of getting from degrees into radians. Okay. So here, if 1 degree equals pi over 180 in radians, now I have a way of calculating. In your calculator, what you're going to want to do is you're basically going to want to ignore the pi for now. You're going to want to just take those two values, okay, and find out what's that fraction. Because as soon as you put pi, your calculator explodes. It can't do a fraction anymore. So what do you come up with if you go 315 divided by 180? What's the fraction for 315 divided by 180?
7 over.
There's usually a conversion button on your calculator. I don't mean to make you think that hard. Just
7 over
7 over 4. Okay. So it'd be 7 pi over 4. Okay. I'll help you find those fraction buttons if you can't find it on your calculator. 240. See if you can convert 240 into radians. 4 over 3. Yeah. So this one, when you do the conversion, which is 4 pi divided by 3. Okay, so I know the whole thing was like, wow, that was a lengthy explanation, but basically the punchline boils down to this is the conversion, and this is why we have the conversion, is 360 degrees equals 2 pi. Okay, let's try going the other way now. Let's go from radians back into degrees. Okay, so let's think about this. What portion of the unit circle forms the arc length pi over 3? What's that? Yeah, how did you get that so quickly? Sorry? Any ideas? Well, let's start going back to the unit circle, okay? If we can't see it yet, let's do the unit circle. Okay? How much is pi on the unit circle? 180. So that's a good starting point. That's pi at 180. Now I can do pi over 3 because there's 3 pieces of pi. Okay? So if that's 180 the whole way from here to there, How much will pi over 3 be? Good, yeah, it's 60.